And yeah, first, what are the capabilities for XR we have with AI? We basically first just divide it into three key parts, which is vision, which is using like something like eyes, then tracking, where we analyze these images, for example, we receive from camera, and we have audio, for example, to generate audio from text, written text, or to convert voice into written text so that we then can work with another AI on this text. So there's a lot of opportunities. At Vision, I can also mentioning there's, for example, classification of images so that you can classify into different parts, like what you can see in the image. You can also exactly track the position of objects in your image, and you can also segment, so getting the outlines of objects. But actually, all of that we will see today. So I don't want to, say too much, Ellie. And yeah, there's really hundreds of providers out there and models which you could use. We just collected here some of the really leading providers, which we also used a lot and can definitely also recommend to use. So one of them you probably all know, it's OpenAI, which is, for example, ChatGPT. You can send your data there, even images, and get information back. Also, NVIDIA is an important one. They actually offer a NIM service, which is NVIDIA hardware accelerated AI models. We have Roboflow, which we also share a lot about today. And also Virtualytics, for example, is this YOLO model. So a lot of capabilities and Hugging Face, everything. So how does this all work? So basically, what you will do if you want to use AI in XR is you have, for example, here on the left side, the camera image, for example, in a webcam texture, maybe in a different format, maybe just a picture, whatever. And actually, you can convert it into a different format, for example, JPEG or PNG. I say JPEG or PNG because that's like these standard formats. There's some more, base64, for example, which is also indirectly these formats. But you can send these more standardized formats then to the AI API. The same is accounting for the microphone, the voice you generate while talking to the XR headset. You need to encode it into some format which can be understood by the models, let's say. And for that, you first need to convert it into standard formats. But to be true, these processes are quite easy and standard. We also provide them a lot in our AI toolkits. So you don't need to worry that, how do I convert it into the right format for our request? What you can see in the middle is the AI model itself. So we send the information to this AI model. It's called request. We need to have it in some specific format. And then it's processed in this AI in some way. We can just see it as a black box first. There's happening some things. And what we get at the end is just the response. It's an output. It's some data we get out. We can always get information if we look for it, like in which format it is. And what we then need to do is converting this response from the format we have into something usable inside of Unity then, so that we have it available. We can convert it into Unity objects. We can convert it back actually even to the webcam textures again, or to audio Unity Audio here, for example. And very true. That's actually really the basic thing. That's all you need to know. You have data, it's processed by the A model, and it goes out again, and you can use it. A good example is the YOLO model from Ultralytics. It's called You Only Look Once, because basically that was the intention when they was developing it. It's a really general model, at least the base models of it. It's really general, and it was trained on a really big data set. It's here you can see it. It's a Coco data set, and it can basically see all things you can imagine. It was trained on a lot of data. And for example, here it's tracking a bus. It's tracking even the person inside the bus, a person outside the bus. And yeah, you see you have the segmentation, which is the blue outline and the red outline here. Or you also have this bounding boxes, which we can use. So we know in the image it was in this green box, and we can then use it for the bounding boxes for tracking 3D positions of the object itself and things like that. So how to really use this one, because it was, I showed it quite easy before. It's still easy, but you need to see what options you have first to know how to use these models. So actually these options, there's 3 options you can have. That's the first, it's the hosted API. So basically what we have is we have our headset here, and we have a hosted API, which uses, for example, GPUs on the server somewhere else. So we don't need to set up a model. We don't need to think about. We just call via internet from our headset this API, which is somewhere on a server. It's like a website. And we send our data there, for example, an image, and we get data back, for example, with bounding boxes of object. And yeah, the only thing we need to think about is how to use the data after that. The second option, it's the local server, which means basically you set up this, which was hosted before, this entire server, the AI, on your local computer. Which means you need to run the model yourself. There's a lot of tools for that, so don't be scared of that option. It just has the advantage. It's even if the internet is not working, it could still be available locally. It's also much faster, around like maybe even up to 50 times, because you don't need to go through the entire way through the internet. It's much shorter here. And the third really cool way is to run the AI model directly on device, which is harder to integrate because, like you can imagine, on this small devices, I would consider this already quite small. It's really hard to put the big models into it. So you can use that right now just for maybe smaller models, which are maybe not capable of what the big models are capable of. But sometimes it can be really worth it to investigate that for, especially if you have a specific task in mind. Exactly, for just tracking or one object, for example, or things like that. And yeah, they have a lot of advantages and disadvantages. What I maybe just wanted to mention here is that the hosted API is easy to set up, but you have problems maybe with the internet connection, which takes a lot of more time. It also has additional cost, maybe. You need to pay the provider for using the AI. So there's a lot of free services also available. We will show it later, but that's the points for hosted APIs. For the on-device inference, it's a different order right now. It's really, really fast. You can track really objects in real time, like 100 times even up to 100 times per second. It also depends on how often you can get the image from your camera, but just to show you how fast it could be. And yeah, it's limited to maybe some formats or sizes of your models. Yes, and the local server is something in between both of them. It basically maybe even combines the advantages and disadvantages of both. But like I said, we will go more into detail later for that. So I just keep it open. Yeah. What takeaways do we have from this part? It always depends on you need to find the best model, which is good for your use case. We provide a lot. We will just share it in some minutes. But what you need to use or want to use, it really depends on your use case. So really, you maybe need to do some research. Which one would work, which solution would work best for you. You need to take care, have maybe get an overview of what providers exist, what models they offer, and just look into like how to use them, what is the data they expect from you, what do they put out. You can basically see it like I said, like a black box. You don't need to know what is happening inside, but at least you should know what is going in and what is going out and how to use that for your advantage or for your project. Exactly.